Let's have a look inside this barricade then. It's not too hard to open up. I've removed all the screws already. I actually haven't had the screws in at all since completing it. I did. Shut up, seagull! Stop stomping on the bloody roof! I haven't had screws in it at all since I started making it. So when taking it off, I've just got to be careful of the little plug down here. Under that. And there we have it. So this here is just an interconnect. It plugs onto this, and that's just got the signal wires for infrared beam that goes across the magazine. There's one on the other side you can't see, and the safety switch there, because the signal for the rev trigger here goes through that. The power from the battery is coming through this XT30 connector. It's basically a miniature XT60, and the number, the 60 or 30, indicates what current can go through it. So I realised that these are completely fixed in place. So as you close the shell, those align and just make perfect contact. This is the back of the flap on the magazine there. So there's you can just see that spring returning it. Original cage here, Rapidstrike flywheels, which makes that gap there a bit narrow, but it doesn't crush enough. There's a lot of dart slippage and fairly poor performance. Original motors, and the wiring for the LED at the front here is just coming down through there. How I did that is I got a block of perspex and I cut it down into shape and then drilled 2 holes up in the bottom, 3mm, and then I put a white 3mm LED, just plugged it into the hole and glued it, and then a green one next to it. So that is 2 separate LEDs. It's not a bi-colour one or anything fancy like that. And they just light it up like a light pipe. And that wiring goes under the cage and comes out there. You can see fatter wires going to the MOSFET, which is behind the cage. And that's just got a single signal wire coming up, and it's got its pull down resistor on with it. But how barricades work normally is you've got this section here, but it is further forwards. There's a gap between this lug and this lug. It allows you to pull back just halfway and rotate the cylinder, and then if you pull all the rest of the way, then it pushes on this and the pusher comes forward. So what I did is I cut that off and I moved it back, so the moment you start pulling the trigger, it's sending the pusher forwards. I could have just put a block up at the front of the trigger here so that it would start halfway back, but I wanted it to be as far forward as possible here because I've got big hands and long fingers. So having a trigger that's there and then it's starting here and then going back from there is far too close in my hand. And this is just a cheap power tool trigger that I got off eBay. I took out the little lock there, that would be a little thumb lock so you can lock it on. That's obviously useless for these purposes here. Just down behind here you can see the voltage meter that I got for this. There's a switch, there are the LEDs. We don't need this anymore. So the power's coming in here and it's going along behind this. But in here is a Digispark, which is basically an Arduino, sitting on top of a custom circuit board. That's version 1.1 because the first version was wrong. I had a lot of issues with this, which is why it's taken me so long to complete. I sort of put it down for 8 months and didn't get back to it because I was very disheartened. Something I learned the hard way is if you get a knockoff Digispark clone, that P5 there, which is the 6th channel because it starts at 0, it will be a reset pin rather than just a a GPIO pin. That means that if you put something like a transistor on there, like I did, and power it up, it will be in a constant state of reset, and you'll think that something's broken or your program is crashing. So that had me going for a very long time. I finally figured out, and there is a way. I found someone describing the procedure to set the fuse. It's called a fuse. It's just like it's like an internal setting that you can't unset easily, and that changes it from a reset pin to a normal GPIO. I also blew up 2 or 3 of them in the process of doing this. One seemed to be a power supply issue, which is under. I pop this out. There's nothing holding it in, it's just jammed in there. Wrapped it up with tape, but that's just a little 5-volt step-down converter from eBay, nothing fancy. The highest current draw load it's got is the LEDs. That's really all. Oh, those LEDs plus the infrared transmitting one, which I forget which side it's on. So that's the infrared emitter, and that's actually running at I think that's running at about 25 milliamps, whereas these LEDs are running I think 20 milliamps each, because I don't want to burn them out. Another issue I had in this project was that this joint here had been fine the whole process until I was preparing to do this video, and then it decided to break off, so I had to quickly super glue it back on. The solvent welder I had used doesn't actually dissolve into this, whatever this type of plastic is, so it hadn't stuck properly. I think super glue would be better, but still, I don't expect this to last forever. If it breaks off again, I will probably just do what I said I didn't want to do before, which is put a normal trigger in there and just pad it out so it starts halfway and goes the rest of the way when you pull it. Having said that, I wouldn't really recommend doing this at all on a barricade because of that, and because of the issue with the cage being for a barricade where the wheels are wider apart. I'd recommend doing an internal magazine mod, but on a Strife instead, because Strife doesn't have that problem and it doesn't have the trigger problem. It would be much easier and simpler. I just don't have Strifes available in my country. A Strife in New Zealand costs about 45 New Zealand dollars used, whereas barricades are very easy to get hold of. You can get like pairs of them for $20. It would be cool if there was a 3D printed flywheel cage full of barricade, because I have about 4 or 5 more barricades sitting around. And if someone else were to do this, I would recommend not cutting this where I did. I'd say cut it down the middle. It's just so much easier to get your finger in there and shove darts in faster without this here. So here's one last close-up look at the inside.